What's up, Robin? Share screen. We're gonna get started in maybe 9 minutes, just to let a couple more people filter in. Is the screen share good for you guys? Everything look okay? All right, nice, thank you. Where are my notes? Whoa, the president himself is in the Zoom call?
Hey, it's me. I'm here.
Nixon, have you seen the memes of the Ukrainian president just being cool?
I have, actually.
You should recreate some of those pictures.
Oh, man. I don't know if I'm that cool. Although I am holding my brand new EGaDS t-shirt right now. So maybe that does make me very cool.
Oh.
So, oh ho. Oh, I'm excited for tonight's workshop, Alex. Quite excited.
It's gonna be sick. This is like a game project on, what's up, Jake? Whoops. On screen right now, that's like a game project I saw on Reddit that was using cool. Like low poly terrains, and it really inspired me to want to try to do something like it.
Nice.
For now, if you guys haven't downloaded the Unity package that we'll be using for tonight, make sure that you have that downloaded. It's in the EGaDS events channel. And it just has a couple of the assets that we're going to be using today. You know what? Since so many people are on Zoom today, I'm going to turn on my camera. Whoa.
Blessed.
Yo.
We've been blessed. How are you doing today, Alex?
While we're waiting, I might as well show off the Reddit post I'm talking about.
Oh yeah, do it.
But first, I'm gonna log out of my profile.
Good idea.
So this is what inspired it, this workshop. Wolf game.
That's really cool.
Yeah, right? And I talked to the person who actually made this, and he said the way they made it was like a low poly terrain asset, the Unity terrain tool, and some volumetric lighting. So I think what they did is they handmade it. And today we're learning how to not hand make it and have a computer do it for us. Oh, Robin, I killed you in Overwatch. Good. Okay. I'm just kidding. That's kind of funny. It is funny though. Okay. I'm gonna keep on getting stuff set up. And we will start soon at 6:10. If you haven't already, start up a new Unity project, just because that can sometimes take a while. I'm gonna create a project. Open it when it's done. And today we're going to be focusing more on the demo. These slides are like for some basic information, just in case we don't have, just to cover some of the basic knowledge that we need for what we're doing. But yeah, we're going to be mostly inside of Unity today. Get this loading screen on board. Did you guys know that most loading bars are like not accurate at all? Yeah.
Oh God, it's loading. Oh man. I usually, as a kid, I thought if you run the like eating your mouse
oh. like curling.
It was like that very end, and it's like you gotta go just to get past the So I just rub it, and then like I thought that just made it go faster.
That's
and then I
funny.
look back on it, I was like, so stupid.
Maybe one developer did that, and then just like it never happened again, just to mess with you, and that's why you have that misconception.
Just turn your monitor 90 degrees to the right. So that actually
go. Oh, true. Wait. I think this monitor can actually do that. No, it can't.
Yeah, it doesn't look like.
All right, my Unity project is open. It's 6:10. Let's start. All right, everybody. Today we're going to be talking about procedurally generated terrains, and we'll be making our own procedurally generated terrain in Unity. This is something that I wanted to do for a really long time. It's something that's not, it's something that I kind of figured out how to do after seeing some videos on the same topic. But today we're going to be using some pre-existing scripts and some procedural generation to make something really cool. So like I said before, make sure that you have a Unity project open. Ideally, it'll be a 2020 version to avoid version differences. I hopefully it won't cause too many issues if there are differences though. So let's go over some examples of what procedural generation can look like. maybe you think of this or Minecraft knockoffs, but all of them are using procedural generation to create these levels of elevation, different coloring, and spawning of objects. Yes, David.
Where's the actual Minecraft?
It's not here.
Why is it not here, Mr.
It's too basic.
Are we making Minecraft? We make Minecraft now?
Yeah, everybody's asking why Minecraft isn't here. It's because it's not good enough. And this looks like a fishing game that you would buy on the PS1. I've actually played some of those. They're kind of fun. Okay. And our goal is to make something like this. Something you might notice from all the other ones is that they're either making use of block prefabs or like objects, or they're like smoothly shaded with some texturing, or just like smooth shading. What we want is a low poly looking environment that has this kind of flat shading effect, which is achieved by having a shader and shading these faces like they're completely flat and completely level. And let's talk about one very important concept before we go into the demo. And that is Perlin noise. So Perlin noise is the main thing that we're going to be using for our procedural generation. Unlike how you just like, whenever you need like a random value when you're creating something, instead of just using like a random.range, you would use a Perlin noise function instead. And the main difference is that for a random.range function, it'll just look like static. And sometimes you might want to use that, but in terms of procedural generation, it usually doesn't look good if you're just using pure static. Perlin noise will give you sort of a hilly effect, because you can see with this texture, it kind of goes from black, but then like slowly a little bit more to white. And that gives it a much more natural feeling look. Another advantage of Perlin noise is since you're getting this kind of texture in your procedural generation, it's really useful, but it's also infinite. You can extend this texture as much as you want, and you'd be able to make as much space as you needed to. Perlin noise is seamless, so that's because it's infinite. Most of the time, if you were to like put a texture on something like a 3D model, for example, your texture would be repeating, right? But most textures aren't designed to be looping, right? So it would have this ugly seam here, and Perlin noise will not do that. And one reason for that is because it's pretty much just a function. Perlin noise is a mathematical function that takes in a x coordinate and a y coordinate, and it will just return a value between 0 and 1. So that's what this is. That's what this is represented by. The black is 0, the white is 1. And we can use this with like x and y coordinates, and that will produce this sort of pattern. And since it's just one function, it's just mathematical, it's fast, and it's really adaptable for whatever you want to use, because you can change those inputs. Okay. So I'm actually going to go into the project now. I need to make sure I have my package downloaded. I forgot to download it. let me download that. Open up that. Download the package. Download. And I can just drag this into a Unity. Oh, I need to have my project tab open. Drag this into here. Import. Yeah, Mason, you just missed some talk about what Perlin noise is. Pretty much just how it's a mathematical function with two inputs, an x and a y, and it returns a value between 0 and 1. And also kind of like the difference between using just random values like random.range and Perlin noise. Random.range looks a lot more like static. Okay. So I have my scene open. I have all my package stuff imported. Let's talk about what's in this project right now. So right now I have an environment folder. This is from a package I found on the Unity asset store. It's just some low poly desert models like rocks, that kind of thing. And I use some of these later on. Some materials that we're going to be using to put on our terrain. I think this might actually be, we don't need that. Yeah. I think that's the default scene that Unity gives us. What we're going to be using is the scene called scene, this one, in the top assets folder. It should have a grid inside the hierarchy. Okay, so it has, this grid object has a single script on it. It's called grid script, and I'm going to show you what it does by pressing play. Oh, okay. Exactly. We have a square. So something you might not realize though, by just looking at it, is that this is a generated mesh that our script made. And our script generated the vertex values for this mesh. So you might see like each of these intersections here, that's a vertex. And that was calculated by our script, put on the mesh, and then finalized into an actual object. It has some variables, cell size, xz size, and cool. Now we know that we can put vertexes on a mesh. Let's actually open that script now. This might take a while. Is it like this? Okay, my IDE is open. And in the Zoom call, if this is too small to read easily, let me know. So let's break down this script a little bit. We have a required mesh filter and mesh render. Those are just the kind of components that we need to render a mesh. We have our basic terrain variables here. You know, just cell size, dimensions. And we have some private variables here. Mesh is where we store our procedurally generated mesh. Same with our vertices, procedurally generated vertices. And we have an IEnumerator. For those of you who don't know, IEnumerators are used to just add delays within your scripts. And you might have saw it before with like how the platform was made square by square. That's because it was an IEnumerator. All right, let's talk about this. This is just making the mesh, making the vertices array, and some stuff for graphics, for the graphics side, UV and tangents. This is where we actually make our vertexes. It's very simple. It's just going over our dimension sizes, putting those into vector 3s, and then that's graphic stuff again. So really, this is the only line of code that matters here. And then this is more generating geometry stuff and more graphic stuff. Once we have our vertices, we actually make triangles out of them, which are the actual faces that we see in game. And this is where the delay is, the yield return null that waits a frame every time it gets run. So every time triangles are made, it waits a frame before making the new one. Okay. Cool. So now that we've seen what the script does, it just makes a flat plane out of vertices. Let's talk about how we actually want to alter this a little bit. The first thing I want to do is to add a just a basic Perlin noise to offset the Y positions of these vertexes right now, because it's completely flat right now, right? I want to have some variation in elevation. So the first thing I'll do is I'll add some public variables. I'll add a public float height amplitude. I'll also do a public float zoom factor. And I'm also going to do a public float vertex offset. I'll wait a second for that. And what we're going to be using these for is our height amplitude is going to be multiplied by what we get back from our Perlin noise, because Perlin noise returns 0 to 1, right? So we're going to multiply that by something to give it a max height of height amplitude, minimum height of 0. Okay, so let's implement that before this. So before we set our vertices, and the line of code that we're going to do is, I want to make sure I get this right. Okay. We're going to define a float terrain noise, and we're going to have that equal mathf dot Perlin noise. And we're going to put in x times zoom factor. Oh, whoops, z there. Okay. So for a zoom factor, let me go to the slides to visualize this. So if you're multiplying your X and Y that you're inputting, it's almost like scaling up your Perlin noise or scaling it down. The larger your zoom factor, oh, you know what? I think I named them kind of incorrectly. The larger your zoom factor, the more zoomed out it's going to be. So it's almost going to be like, you know, it's going to look like this instead of the overall one. And if your zoom factor is really low, it's going to look more zoomed in. So this is useful, right? Because the more you zoom out, the more it looks like static. The more it looks just like random pixels. The more you zoom in, the more you get these kind of rounded shapes, these kind of hills and also valleys. So we're going to make sure that we have all of this. And then in our turn, we're going to use our terrain noise and put it into Y and multiply it by height amplitude. Yes. X and Z. This IDE just tells you what the parameter names are. Those are parameter names for the Perlin noise function.
Okay.
Yeah, so if you see here, like the Perlin noise definition is, yeah, it takes in a float X, float Z.
Okay.
Yeah, and my IDE is just telling me what the names are. Same thing as down here, you know, in here. Okay, I hope that everybody has this code. If not, I'll be going back to it. Oh wait, I didn't set my variables yet. I always forget to do that. Still flat, cool. Oh my God. Okay, so height amplitude, we're gonna go with 4. Zoom factor, let's go with 0.1. And vertex offset, oh, we haven't used vertex offset yet. Okay, so we're gonna press play. Hi, do you need to get caught up on?
No, I've been listening.
Oh, sick. Okay, cool. So we can see here, we have a slightly generated terrain. Woo. Awesome. Oh, and just as a note, this already includes the flat shader attached to it. So you see this flat shading. Digo, you had a question?
Yeah. So you said like the zoom factor is less than 1. So we're like zooming into the map, like your visual example?
We are zooming out.
Oh, we're zooming out.
Yeah.
So okay. So that's why there are bigger changes between these.
Yeah. So let me give a different example. Say we were gonna do like 20.1. Something weird about Perlin noise too is you can't use whole numbers on this zoom factor, or else it's gonna return the same value for each vertex, and you're gonna end up with just a flat plane again. So you need to have like some sort of decimal amount. But say you had 20.1. It looks a lot more jagged now, right? And that's because it's zoomed out, so it's more staticky.
Oh, okay.
Oh yeah, I said it wrong before. At lower values, it's zoomed in. It's zoomed in, and right now it's zoomed out. And you can see it's a lot spikier, and maybe that's what you want. But you need to know the difference pretty much. Okay, so let's turn it back to, that's not gonna save. Okay, Something else you might notice right now for our terrain is that it's very uniform. If you see these squares, these are exact squares. Maybe you want that sometimes, but we don't. We want it to look a little bit more organic. So we're gonna do a new thing. So you remember that vertex offset variable that we added before? Let's actually use that now. What we're gonna do with that is we're gonna do something like float rand x offset equals random.range and put in our vertex offset in both fields. And this will return a random value between those two values. We'll duplicate that by doing Control D and also make one for Y. So we're making two different variables for this here because we want them to be separate values. I did actually make a mistake while making this code where I used the same rand x offset for, wait, sorry, this should say Z. I keep on forgetting. I used the X one for the X axis and the Z axis, which wasn't the behavior I was expecting, but it did end up looking kind of cool because it gave me these kind of like slices since it was warped in both axes the same amount. And that looked kind of cool. I can show you guys what that's like later. Okay, so now that we have these variables, we're gonna put them into here. Yeah, we're gonna add rand x offset to the x value there. And we're gonna add the Z one here. Okay. I'll wait a little bit just in case anybody needs to type. Okay. We're going back. We need to set our variables. I didn't forget this time. And after I show this one, show off this one, I'll pause a little bit for questions, just in case anybody's curious about what this progress is like. If you want to see something that, or like you have a question about what procedural generation can make, I can answer those questions too. And we're gonna use 0.5 as our vertex offset. You know what? I'm also going to increase the size of our dimensions a little bit. I'm gonna go 30 and 30. Okay. All right. Now, when we look at the wireframe, we can see these vertexes are a lot more organic. They look way more organic now. I'll go to our shaded mode. And you can see we are already getting this, we're already getting this super cool effect with that speckling, kind of like that crystallization look. And you can play around with this even if you change up your directional light a little bit, if you rotate it in the EX. You can kind of see how different levels of light affect how it looks. And it was pretty simple to get here, right? It was, you know, we did use a pre-existing script that was generated in a mesh, but we added procedural generation to it to create these this new looking asset, in addition to another pre-made asset of the flat shader. Okay, so I'm gonna take a pause here in case anybody has any questions. Zoom chat or otherwise. And yeah, you can just ask me about anything about like what procedural animation or procedural generation can do, how I thought to do this, anything. And if we don't have any questions, I'm just gonna show off another inspiration for this workshop. Ego.
So like, my understanding is like a noise map. You put in like a coordinate, it gives you back a value based on that, right?
Yeah, pretty much.
So since we have like, we're always putting in the same coordinates, we don't have to go the offset, the random offset. Would our map always look the same?
It always looks the same. And something we can do to counteract that is instead of just like using the same X and Z every time, we can have another variable that we randomly set at the start of every runtime. And we just add it. We just add it over here. We add it inside. Yeah, pretty much. I didn't say it was boring. I said it was basic. All right, you know, Diego, let's just add that right now. Why not? I actually want to add it above the terrain variables because we can use it for different noise layers as well. Let's say public, it can be private actually. Private float, random offset, or actually, let's call it seed offset. And in our awake, before we call generate, we'll set it equal to random.range 0 to, it doesn't really matter what this is, but in tutorials I've seen, it's usually just a high number. It doesn't really matter because it's all random. If you offset it just like a little bit, it'll be completely random technically. Okay. And finally, now that we have that, now that we've randomly generated a seed offset, we're going to add it here to both X and Z. This is kind of hard to see. Do something like that. Okay. Now it's going to be different every single time, I hope. Do you have any other questions? Wait, sorry, 1 second. David.
Could we make our own noise functions, Alex?
You can, but it's hard. I think it's hard. Prolonged noise is used a lot because you can see like it's this small hill that's very much so like a natural looking terrain thing. This kind of hill that moves along this line, that's very much a terrain thing. And if you're gonna make a terrain function, you know, it needs to do something. Well, that's your problem. Rayhan, I'll get you next. How do we get the code into Unity?
Sorry, like how you said you had to do something in order for like the code to work.
I'm not sure what you're talking about.
Sorry, it's like after we wrote the code down, you had to like go to Unity and like do something with the variables.
Yes. I'm just setting these public variables over here. So if you can go into the hierarchy over on the left, click the grid object, scroll down until you find this grid script, and we're using these values. Can you see those?
Yes.
Okay. yeah, just copy those down, and we can and you'll get like an effect similar to this. Noah.
There's a GDC talk on YouTube from 2017 where a guy goes into very much detail on different noise algorithms. You want me to link that in
Ooh,
Discord?
yes, that sounds good.
Also, I've stolen a noise algorithm from this guy. So
Oh, really?
totally stealable code if it's like
So, okay, we are only using Perlin noise today, and we're using it in different ways because I want to more focus on like different methods of using Perlin noise functions instead of like using different ones. But I've also linked in my slides a link to an article about different noise functions because there are a couple of different ones. So that'll be nice for you guys to know too. All right, if we're good here, Rayhan, is it working?
Yeah.
You got it? Okay, nice. Emilio, do you need to see anything? Your name's Emilio, right?
Yeah.
Okay, well, do you need to see anything code-wise?
I think I'm good.
Okay. Yeah, feel free to stop me because I intentionally left some space in this workshop for questions. Okay, so now that we have this charger is not working, I need to move this. Oh, no wonder. Okay, it's working now. Let's move on to another section. Okay. Let's add a new variable header. So headers are pretty nice in Unity. You can split up your variables for organizational purposes. Let's call this header mountain variables. And we're going to be adding pretty much the same things. So public float, mountain, height, amplitude. Don't do that. Public float, mountain, zoom factor. Okay. So once we have these two variables, we're going to create another Perlin noise layer. So we already have this noise, right? Beneath it, we're going to make another layer of noise. We're going to do a float mountain noise. We'll also be getting it from a math.purloin function. And we're going to be also putting in x. We're going to multiply it by the mountain zoom factor this time. We're doing the same for z, also by the mountain zoom factor. I'm not gonna add on the seed offset just because I don't want the function to be too long, but you would also add the seed offset there. And finally, I'm just gonna multiply it by the amplitude right now, not that one. I'm gonna multiply it by the mountain height amplitude. So you might be thinking, why are we adding another noise function? Doesn't that just, isn't that the same thing? Well, what we're going to be doing is we're going to be using a different zoom factor and a different height amplitude. So it's gonna be like if you're layering on top multiple Perlin noise maps, you can have one map have a much greater effect on height than the other one. And you'll see what I mean when we demo this. So copy down the mountain noise, and down here where we calculate the vertex height, we're also gonna add the mountain noise here. So once we calculate it, we add it to our Y. Adding mountain noise here. And we have, you know, define it here. I will wait a little bit. I'll go back up to the, yeah, they're just floats. Pretty much every single variable we're going to be using today is float. All right, let's go into here. Height amplitude, let's go for 20. And for the mountain zoom factor, we want it to be zoomed in more than our terrain one, right? Because we don't want like thin mountains, we want very wide mountains. So instead of doing 0.1, we'll do like 0.0, 0.03. Let's test it out. Okay, so you might be able to tell now, there are some sections of this terrain that's much higher than the other ones. Before you saw that it was like mostly, it was like decently even, small bumps. But now that we have this mountain Perlin noise, you can see this huge hill over here. And that's definitely caused by our mountain layer. We can zoom it out even more. Also, I'm gonna remove this delay down here because it's making the terrain generate kind of slow. So to do that, we need to delete the yield, make this function from an IEnumerator into a void instead, and remove this start coroutine around the generate. So I'll go over that one more time. We're gonna remove the yield return null that was in this for loop down at the bottom. We're going to make this from an IEnumerator into a void, and we're going to remove the start coroutine around the generate. And that's just to make it generate immediately instead of with a delay. Okay. What? Okay. Immediate generation. Cool. And this mountain thing, it's kind of hard to visualize without a larger terrain. I can do 100. I keep on forgetting. I need to do it outside of play mode. Wow. So you can see, right? This is a little bit more complex than just having one Perlin noise function, because you can see these hills, right? And these hills would be generated by just the mountain layer. but also these little bumps here, these little bumps on top of the hill that are caused by our base terrain layer. Okay, let me also show you guys something else you can do with multiple layers. Say that we want something that kind of looks like plateaus. We don't want mountains, we want more like sharp walls and flatter tops. So maybe we do something like this. Maybe we say our mountain noise will equal, we'll use a ternary operator here. If mountain noise is less than 0.8, and then times mountain height amplitude. So if it's below a certain value, let's make it 0. Otherwise, we'll keep it the same. If you haven't seen this before, it's a ternary operator, and it lets you do if statements in like one line. It's pretty much just a simplification. But what we're doing here is we're saying if your Perlin noise function returned less than a 0.8, and we're multiplying it by amplitude because we multiply amplitude here. If it's less than 0.8, it's just going to zero it out. And that Perlin noise function is going to have no effect on our terrain. If it returned a point higher than a 0.8, then you will have your mountain terrain. So let's just check this out. Oh, cool. Right. So that might be a little bit too much, right? I kind of want more plateaus than this. I also don't want them to be as high. So I'm gonna make this into a 5 instead. And I'm gonna lower this threshold. I'm gonna say maybe like 0.5. Does anybody need to see the code for mountain noise? Okay, I'll go back to demo. And wow, cool, plateaus. So you can see this really simple manipulation of your Perlin noise functions can result in some really complex, really complex terrain behavior. Because say you had even another Perlin noise layer, maybe you could have two-tier plateaus. And this is kind of like the basis of procedural terrain generation. Okay, let's do something a little bit more interesting now. So we know how to modify our terrain. We know how to modify the procedural generation noise that we're using to make it. Let's spawn some objects on our terrain. So this is going to be the last thing that I do, and anything past that, it's going to be more chill, just like messing around on what kind of things we can do. I know this is kind of a slog because just so many variables, so many layers, but this is going to be the last thing that we do. Header, tree variables. And we're going to be doing public float tree threshold, public float tree zoom factor, public float or public game object, tree object. So we're going to have these three variables. We're going to make another noise layer. Float tree noise. And we're going to do it the same way we've done everything else. X times the tree zoom factor, Z times the tree zoom factor. Oh, I didn't know. That's convenient. Cool. And we're going to do something kind of similar to what we did for the mountain noise. We're going to also take a cutoff. Yeah. Oh, actually, sorry. My bad. We're going to be doing an if statement, actually. Tree noise. Or if your tree noise is greater than the threshold that you set, then we're going to instantiate the tree object that you put into it. Wait, dang it. I put this in the wrong place. We're going to move that underneath our vertexes, actually. So after we set our vertex value, we're going to say, if you can, spawn a tree, spawn it at that vertex, vertex I position, vertices. And, you know, just a rotation doesn't matter. And this block of code is going to say, every so often, spawn a tree. But it will automatically use that vertex height and position, and it'll populate our terrain. So let's go find that tree we want to use. Wait, okay, I put it in here. You can feel free to use any one of these. It doesn't really matter, but like you can put a cactus in the snowy area. But I'm gonna use the flat tree. The threshold. Let me check what I put. Threshold is going to be 0.9. The zoom factor is going to be 20.1. And that's because we want it to be very staticky. And let's test it out. And as you can see, boom, trees. You've got trees on your environment. And you might be able to notice the trees on the plateaus are using the right elevation, so they're higher than the trees below the plateau. So yeah, this is kind of the start. This is kind of the start of actually having terrain generation, populating it, and just having an interesting world to look at. Like, imagine just walking along this terrain. Wow. Whoa. Exactly. Oh, true. We can put a procedurally generated Lorax. Yeah, Jake, you can have the Lorax model. Oh my God. post a GIF or a screenshot of that?
Can you do it again? Can you turn down the refresh one? Just put it to like 0.5 or something.
Oh my god. Can you also make the prefab scaled a lot higher? Okay. Sick. Okay, but yeah. This is pretty much what I wanted to show off. And I hope that you guys found this interesting. I hope you guys found it helpful. Does anybody have any more questions before we kind of like wind down and do more of just like, you know, exploration of this? You can ask some questions, that kind of thing. David.
Oh, my computer's gonna crash.
I want to see it.
Oh no, it was horrifying. It was just horrid.
I want to see it.
I don't want to crash my computer.
I want to see it.
No. Just like make it like 5.1 or something.
5?
Make it like 4.
That was scary. It actually could have just killed, like, bombed this blue screen on my computer. This thing is not meant for thinking.
Whoa! Whoa! Oh my god! Oh Jesus Christ! Wait, do you guys want to see?
Oh no!
They're all in sync.
Yeah.
You know, you can set a animation offset for things.
I know.
So you could have them all going wild at different places. Mason wants the screenshot. Mason wants the screenshot, Jake. You got to do it for the president. Okay, wait. What if you just send me? Actually, not. Never mind. Okay, cool. I did also have something planned for like showing biomes, but it's pretty much the same thing. You just add another purloin noise layer, but instead of changing the vertex positions, you save that into an array, and you know what vertex belongs to what biome. And that's pretty useful. Like maybe I want my trees in a certain biome to be a lot bigger. Maybe I want a different type of tree to grow. Maybe I want a different color for my terrain. That kind of thing. Also, I think it's kind of cool if I change the color of this. The shader I'm using is kind of weird. It desaturates everything. I'm planning on fiddling around with it more to make it like more translatable to different lights. But yeah, you can do a lot with this. You can do a lot with these basic principles. Does anybody want to see me try to do something? Yes.
No.
Oh, okay. Yes.
Make Minecraft.
No. No. That's a deal breaker. What is something I wanted to do? Maybe. Does anybody in Zoom want to see something? See me try to do something? This is all pretty basic. Digo.
If we put a mesh collider, does it just work?
It'll work. Yeah. I'll show you. Because it is just a mesh, right? Mesh collider. Convex. I don't really know how mesh colliders work because they never like
work.
They never like wrap to.
So they never work.
I don't know. I think I just don't know how to use them.
Does it have to be like concave or something? No, it like interpolates between the points that you put, and the interpolation is a little whack.
So let's put the sphere above the grid. Mesh colliders have a max number of faces. If the shape is too complex, it's not going to get every face. That sucks. Oh well. Okay, so I'm going to put a rigid body on the sphere. And it should hopefully bump into the mesh collider. Kind of scared it won't, so I'm just going to make it convex. Bonk.
Floating in the air, absolutely, yes, that doesn't matter.
Yeah. I don't know how to fix it. Robin also says, can I randomize the trees too? I definitely can. I can either just choose to make these trees random on their own, or maybe I can do another Perlin noise layer to determine what size the trees are and that kind of thing. Okay. I think there was like one thing I wanted to try to do. Maybe. Wait, okay. This is off topic. Did you guys know that there exists a Unity Chan?
Yeah.
Spawn her in.
I'm downloading it. It's downloading. It's like a surprisingly large package too. True. Dude, honestly, it's like really detailed.
I wish my IRL toothbrush had that many polygons. Actually, stop reading that many polygons.
What other? Oh, there are some. So with this kind of procedural generation, you're never gonna have caves. There's a really cool way you can do that. Because you can make a 3D Perlin noise. I don't know, but like it's pretty cool because you can have that 3D Perlin noise. You can apply it to your terrain, and then you can just carve out areas in your terrain. That's pretty complicated though. I link somebody who did do it though in here. This one. Oh yeah.
Sphere, and then sampling a 3D noise function at each point and stretching those points in or out based on that noise value. By mixing in.
So he made he makes a lot of procedural generation stuff, and he made a system that like procedurally generates planets, but he wants to be able to actually have like overhangs in his planet. I'm trying to figure out where here it is, I think.
Here's what our 3D texture looks like now. So let's once again use our matching cubes to construct a mesh. It looks like we're getting somewhere at last. Unfortunately, with this technique we do occasionally get random rocks floating in the air. When the value is below 0, those are rock points because they're inside of the computer's values classified as either air or rock, and will match.
What? A little bit.
Through that space cube by cube, constructing the surface mesh for each one as we go along. This matching cubes
It uses
algorithm
a
was
3D
published all the way
noise
back in
prelim
1987
function,
with the purpose of
and
visualizing
based on the
results from
value that the
medical
prelim
scans,
noise function
but
gives
it's
back,
perfect for
it
games
makes
as well.
shapes like this.
I'll show the code for this
Pretty
quickly
cool,
for
you know, like,
anyone who
look
might
at
be
that art.
curious. So the bulk of it is actually just a giant.
Yeah. Yeah. He didn't figure this out. It was just like known. Pretty good. Okay. Is there anything anybody? Oh my god. It's still downloading. Yeah. Oh wait, does she have voice lines? Oh my god. I didn't even know that. I did not even know that.
Alex, we're going down the rabbit hole maybe a little too far.
Wait, is she a Vocaloid?
We went to Ego's computer. There's just a folder of like 15 different Unity.
Oh, it's done. It's been done.
Where is it? Oh god, it even has an exclamation point.
This one. Unity Shan. Woo! God. I am. Cool.
Yo, default material. Oh my god.
Yo, flat shading.
Wow, this is fantastic.
Flat shaded.
This is too good. Games 2022. Oh my god.
Oh, that is.
Give her back skin-colored cheeks.
Cool. All right, I guess we can wrap up here then. Now that we've done the important thing. All right, I'm gonna stop Zoom call now. Thank you everybody for coming. I hope you learned stuff. I hope you had fun. Also, thank you everybody who came in person. I enjoyed putting this one together. It was a lot of fun. Yeah.
It was really cool.
Thanks. All right, I'm gonna end the Zoom call now. Bye-bye.